Now it is our third lecture of the chemical bonding. Let us start with the orbital concept of overlapping. Discuss orbital concept of overlapping for formation of covalent bond. So orbital concept, according to this concept, a covalent bond is formed by the overlapping of half-filled atomic orbitals either on the internuclear axis or by sideways. So a covalent bond is formed by overlapping of half-filled valence atomic orbitals either along internuclear axis or by sideways overlap. Now, types of covalent bond. Number one is sigma bond. Sigma bond is formed by axial overlap of the atomic orbitals. It is formed by axial overlap of valence atomic orbitals of the combining atoms. It is formed by three means. Number one, SS overlapping. Here half-filled s orbitals of two atoms. They overlap along internuclear axis. Example is formation of H2 molecule. This is hydrogen having one electron. This is second hydrogen having one electron. They overlap together. They form covalent bond. This is our molecular orbital. This is overlapping of the atomic orbitals. Then we have sp overlapping. Covalent bond formed by the overlapping of half-filled s and p atomic orbitals. Example is formation of HF. H is having one s orbital. Fluorine is having 2pz orbital. They overlap. Later on, these are fusing. This is molecular orbital. Then we have third type of lobing overlapping, that is PP overlapping. It is formation of F2 molecule, 2pz orbitals of 2 fluorine. They overlap. So these are the three ways by which a sigma molecular orbital or sigma bond that is formed. Then we have other type of overlap by which pi bond is formed. So this was the case of sigma bond. By 3 means it is formed by SS overlapping, by the SP overlap, and by PP overlap. So second type of covalent bond is a pi bond. It is formed by sideways overlap of half filled p or d atomic orbitals. So we have the formation of O2 molecule here. O is having the two half filled orbitals. One of them will be overlapping along internuclear axis, forming sigma bond, while 2pz orbital they overlap sideways. So this is formation of sigma and pi bond. This is O2 molecule. Then we have formation of N2 molecule. It has three half filled p orbitals. So it will be forming one sigma bond, two pi bonds. Py orbital overlaps with py, pz orbital overlaps sideways with pz orbital. So nitrogen is having three bonds between two nitrogen atoms. So this is formation of pi bond. Then we have the difference between sigma and pi bond. First point is the definition of both bonds. Sigma bond is formed by axial overlap of the valence atomic orbitals, while pi bond is formed by the sideways overlap of the half filled p, or it is by d orbitals. Then we have, so first of all, first point is definitions. We have done just. Second is sigma is a strong bond because overlapping along internuclear axis it is always strong, and pi bond is a weak bond since overlapping sideways is a weak overlap. It can be formed independently. It cannot be. ये इंडिपेंडेंटली नहीं बनता है. S orbitals participate in the formation of sigma bond. They do not, only p and d or f orbitals are involved. Fifth is rotation around sigma bond possible. Not possible because overlapping is above axis as well as below axis. If we want to rotate the two atom, pi bond will break, so overlapping is not possible. Then sigma bond consists of a single electron cloud which is present in between the two nuclei or internuclear axis. It consists of two electron cloud, one is lying above and another is lying below the internuclear axis, and we can say that for formation of sigma bond can take place independently, but formation of pi bond first require the formation of sigma bond followed by the formation of pi bond. So these are the differences between the sigma and pi bond. So now we come to another question, very important question, that is discuss the Born-Haber cycle. Born-Haber cycle is used to calculate the energy changes during formation of ionic bond. So we have done up to now two questions. First is the orbital concept of overlapping. Second is the difference between your sigma and pi bond. Now we come to the third question, that is what is Born-Haber cycle, or discuss. Born-Haber cycle. This cycle is used to calculate the energy changes taking place during the formation of a ionic bond. Now these changes, they include five types of energy. So what is the enthalpy of formation of ionic bond? If we want to calculate, we can take the help of Born-Haber cycle, which takes into account the sublimation energy which is required to convert the positive electropositive metal into gaseous state. Then we require the bond dissociation energy which is required to break the bond of the electronegative molecule. Then we require ionization energy, electron affinity, and then in the last it is lattice energy. So five types of energy they are required. So what is Born-Haber cycle? The energy changes involved in the formation of ionic compound from their constituent elements can be studied with the help of thermochemical equation or thermochemical cycle. This cycle is known as Born-Haber cycle. So Born-Haber cycle involves the calculation of the enthalpy of formation of a ionic bond from its constituent elements. So now let us take it is used to calculate enthalpy of formation of a ionic compound from its constituents with the help of thermochemical changes. For example, let us see formation of NaCl. So it involves 5 steps: conversion of sodium solid by giving it sublimation energy into sodium gaseous. Secondly, sodium gaseous, it is given with the ionization energy first, then it forms sodium positive gaseous ion. Thirdly, Cl2 molecule, it has to be broken, bond dissociation energy is given, we get 2Cl gaseous. Fourthly, the NaCl takes up an electron. For this, it releases some energy, electron affinity. So Cl negative is formed. Fifth point, Na positive ion formed above combines with Cl negative ion to give you NaCl. Then it releases lattice energy. So now in this case, enthalpy of formation of NaCl, that is equal to S plus half D dissociation energy plus ionization energy minus electron affinity and minus your lattice energy. So these 5 energy, if we know, we can calculate the enthalpy of formation of the ionic compound, that is NaCl in this case. Now we know another question. Comment upon the physical properties, characteristics of the covalent compounds. Comment upon characteristics of covalent compounds. Number 1 is physical state. Most of the covalent compounds, they exist only in the either in the liquid state or they exist in the gaseous state due to weak van der Waals forces. Sometimes they are solid. If van der Waals force is magnitude, that becomes strong, so their physical state is generally liquid or gaseous state. So, sometimes they exist in the solid state. Second property, we have crystalline solubility of covalent compounds. Since they are covalent in nature, like dissolves like, so organic compounds or the covalent compound, they are soluble in the organic solvents. They are not soluble in the inorganic solvent. Then we have melting and boiling point. They have low melting and boiling point due to weak van der Waals forces. Fourth, combustibility. They have high combustibility due to high percentage of carbon in them. Then they are used as fuel in most of the industrial and domestic purposes. Nature of the reactions, the reactions are molecular in nature. Molecules take part in the reaction. Their solution, they do not conduct under the no conductivity, non-conducting, because they do not produce ions. That's why they do not conduct. Similarly, we can comment upon the physical properties of ionic compounds. On the same headings, we will be comparing properties of ionic compound. First of all, physical state. All the ionic compound, they generally exist as solids. They are rarely liquids, since the ionic force that is very strong. Then we have the solubility. Ionic compound, they are soluble in the polar solvent like water, slightly soluble in alcohols also, but they are not soluble in the organic solvent. Melting and boiling point, they possess high melting and boiling point due to strong inter-ionic forces. Then we have the combustibility. They are not combustible at all, since they don't contain carbon. Then fuels, they are not used as fuels. Reactions are ionic in nature. Instead of molecular, they have ionic reactions, because ion, they get ionized in the solution, and then ions take part in the reaction. Their solutions are conducting in nature because they produce ions, and these ions, they start carrying charges. Then properties, so these are the properties of the ionic compound. You can also differentiate between the properties of ionic and covalent compounds. So this is regarding the all questions of this unit. We have studied 5 questions in our lecture number 3. Next questions will be taken in next lecture. Thank you.